Hi and welcome. You're probably wondering why I gathered all of you here. If you ever copy the directory to _v2 or _old, or rename files to something _test or do not touch, or this is a good version, you've been doing version control the whole time, just manually. And today we'll see how Git automates the process safely, locally, and right here on OpenVMS. First thing that I would like to clarify is what's version control, because OpenVMS already has file generation, so in some terms it already has version control, but it also has the upgrade of the CMS and MMS on top of that, because that's not enough. Version control, in essence, is just keeping history of the changing in your files or your code base. Git will also allow you to branch safely, and we'll talk more about that in a bit. And it also facilitates collaboration. It allows teams to work on the same code base, on conflicting changes, subsets of code, without overwriting one another's change, overwriting files or overwriting somebody else's changes. Even though it was created by a creator for Linux, Git does not require limits. It started out there, but it's multi-platform. It's available on Windows, and as of fairly recently, it's available here on OpenVMS using the GNV package, the GNV tools. And in this talk, you'll learn how to initialize the Git repository, how to track files, branch, merge, and inspect history. So those are a lot of terms that if you are not using Git day-to-day, it's not really, they're not clear. So what's a repository, what's a branch, what's a merge, and how does that compare to what we've been doing on OpenVMS? So this is a little mental model of what are the concepts that are used in Git. So repository is just a directory which is being watched by all the changes made to any file in that directory or any of the subdirectories is going to be detected by Git. And if we tell it to do so, the change is going to be committed to the repository and added to the timeline. VMS analogy would be a project directory or an MMS project. Sorry, a CMS project. A commit is a snapshot in time of a repository. So at any given moment, the current state of all the files that are within the same project will be in one commit. Another analogy in VMS is file generation number 2, but for the whole tree. For instance, if you have if you have 5 files in your project, and then you change file number 2 3 times and file number 4 10 times, one snapshot would be generation 2 of this file and generation 10 of that file, and that's not easy to keep track of. So in that terms, Git's workflow allows going through the timeline way easier. A branch is a parallel timeline. So this sounds a little bit sci-fi. What happens there is that we can have one repository that we will call main or master or whatever, and that's the contents of our project in a production state. So nothing is broken, everything works fine, and that's the branch that's always going to be fine. Then at some point we would like to create a new feature. What we do then is we create a branch out of the master branch. We do all the changes there, and then we don't need to do that in one go. That branch can be long-lived. It can be working for a month, that branch. And our project can be broken for a month in that branch. Nobody will care because our main branch, our production branch, is still stable. Analogy of that would be, if we don't use CMS, would be a test system copy. So we copy all the files of the project to another directory, we do things there, and then we put them back. But what happens, especially with the long life feature branches is that if during our development of feature branch, there was a critical bug in that system, it was patched. And then when we copy the files over, we might overwrite this patch when we need to redo it again. So that's the advantage of branches is that we have an isolated environment, but it's also easy to merge all the changes that were tracked in that environment back into production, even though there were some more changes in production branch while we were working on separate branch in our parallel timeline. And the final concept is merging. It does not track files as copies of different. It doesn't keep the entire files and versions of the entire files in its repository. It just keeps the deltas for what changes were applied to the track files. So say we have a file, we make a change in line 10, it changes to something else, and we change line 12 to something else, and then we commit. When we want to merge that, Git will just reapply the changes that were tracked, the changes that were made to the affected files, to the branch we're merging in. And this is all a bit abstract, so I would like to go to a live demo so we can see how Git works in the real life. This is our x86 box. And we have a directory. We're going to create a project directory. So this is our project. We just created the directory. For the sake of simplicity, our project is going to consist of one text file, and we're going to be making changes to only that one file. So let's create a file. So our project starts really simple. It has one line of text. And if we look at the contents of the directory, it's reading txt, and if we type it, we'll see the contents of our file. This is not Git yet. If we want to track the changes in Git, the first thing we should do is initialize the Git repository, Git init. It gives us a few hints about the naming of the master branch. There has been a lot of talks about that because some people were offended by using master. So at some point, the whole instead of being master, it's called main. But Git is not really opinionated in any way of what's the name of your branch. So you could call it master, you could call it truck, you can call it main, you can call it production. For dev branches, you can call it dev, you can call it broken, you can create a feature branch that's named by your ticket ID, that's named by the name of the feature with the dashes in between. So as far as Git is concerned, it doesn't really care what's the name of your branch. It's up to the user of Git to devise a strategy of how the branch will be done. And this warning that we got is just that the only default that we had was that the main branch was called master, and now it's going to be called main. We initialized a repository, and if we do git status, we were supposed to read release notes. That's for us. All right. And now we can use this. So the Git port to VMS is still fresh, and there's going to be a few things that they're not there that we need to do manually. So let's read this command. Let's try again. We're good. So we created a file, we initialized a repository, and when we check the status, it says we are on branch master. No commits have been made, so no snapshots of the timeline of the project. Nothing was happening in the project. And there is one file that's not being tracked. It's called readme.txt. If we want to add it to Git, we will say git add readme.txt. And if we do git status again, they'll say we're still on branch master. We still have made uncommits, and we have one file that's staged to be committed. That's the one that we just added using git add. Commit is created by typing git commit and then commit message. So we're going to call it initial commit. And now we have created a snapshot of the state of our project. We have one file changed and one line was inserted. So it's not a big project yet, but it's going to be much bigger. Okay, so let's track our first change. If we look at git log, we have one commit and it's called initial. So we want to change our file that's readme.txt, and we're going to add a few lines. Add it to B. Add it to change directories. Did that? No, it's here.
I did already get version 2. Like all.
Huh. Okay. This is new.
Do a dir. No. First, start.
Like this?
Yeah. How did it get to version 2?
Where did version 1 go?
There wasn't one version 1. He just went and edited it.
Okay, and then let's say readme.txt2. We are seeing the same file, right?
Right?
I think when you bring up the editor,
Oh,
it's
top line.
scrolled
Yeah,
up.
scroll down.
It's there, you just don't see it.
Yeah.
Cool.
Oh, yeah, because the red border looks like border of the screen, but it's not.
Oh, you added.
Yeah. There's the other file. Oh,
Yeah.
okay, so it's a little bit bigger. Let me just change the geometry of this window so it doesn't do that anymore.
Just say show term. Get out of the editor. Say show term.
What's that?
Oh, yeah, just set a term / age equal 24. And say width equal 132. / width equal.
Wait, it's not equals 1.
Or 80. Just say 80.
Hey, yeah, it's standard.
All right, now you should be fine.
Okay, let's try. Okay, thank you. So let's track our first change. We will add a new line saying this is a new feature of our app. And let's save the file, and the file has been written, and it's version 3. It will do a git status. It says we are still on branch master, and there's a change that was staged for a commit. So it's not doesn't say the file is not tracked. There it says this file is not what I remember it was. If I do a git diff now, it will say, you see those little pluses at the beginning of those lines? It says this line was added and this line was also added. And this is different from what we have in Git. So we will now do a git add readme.txt. If we do another status, it says this is a change that's going to be committed, and then we will do git commit -m, add a new feature. Git log will show you a list of the changes that were made in our repository. But once we have more changes, it's not easy to track because there are many lines to one commit. So we can say git log one line, and it shows us just the commit ID or the commit cache and the commit message. And for everything else, we should look into the details of what those changes are. So say we have a stable state of our project and we want to start creating another feature. So let's see the versions again. Version txt. One thing from Git's release notes, since Git is not native to OpenVMS, the file generations are not the concept it understands naturally. So in this port of Git and during this version, we will need to purge a file every time before we do any Git change. It will understand when we add when we add changes to the repository. But once we switch branches or check out a file or do any of those operations, it's not going to be. It's going to say the file already exists. Okay. So that is .txt. So our new feature is going to be called feature 2. Oh, sorry, before we do that, I made a mistake, and I'm going to save a file. We have a version 4, and we purged the file.
You can just say purge.
Oh, just that's all.
All lines.
Okay, thanks. It says this file has been modified. Now, what I want to do, I want to reset it what it was in Git, because if we look at readme.txt, we have this error here, and we already purged all the changes. So what do we do with that now? Our good state of the file is still in Git. So we'll say git checkout readme.txt. And it's good. We don't have our even though we made a mistake, we saved the file, we purged it, we still have the old version.
What was the scroll up again? The previous directory. So you had readme text.4. So not only did it,
It also
I was expecting it to rebaseline using version 5, but it made a version 1 that got rid of the other.
File generations are a problem for Git right now. So it does a lot of things, but no, it doesn't do any of them correctly. So the best way to do it is just first file. If you're going the Git way, just use the latest version and purge all the other ones. So you can do the advantages of Git are, we'll talk about them a little bit later, but now at the current state, it gets confused with generations.
You can make controls around this if you want.
Yeah. But I think the next versions of Git port are going to deal with that. So we can have the regular Git load. So say we want to implement a new feature in our project, and it's going to be called feature 2. But we still want our project to be as it was in the main branch. So the feature will make some breaking changes that will have some additions to the main menu, which will point to a feature that doesn't exist yet or is broken or something like that. We want all of that to happen in a parallel timeline while the production branch is still okay. So we will create the branch that's called feature 2. Not easy to type. Git checkout -b. -b means checkout new branch. And now we are at the branch feature 2. So to look at the contents of our files, it's still pretty much the same what it was in the main branch. That's because we just created this branch, and this branch is at this moment identical to what was happening in the main branch. Let's add it readme.txt.
So you're not going to create a parallel directory structure.
No, we're working the same direction. And feature 2, this is our feature. If we look at Git status, so you will do a lot of Git status while you're working with Git. It's going to be one of your best friends. It's going to tell you what branch you're on, what was changed, what was not. We've modified this file, so git add. This is a shortcut, so we don't need to say file by file. We'll say git add dot. That means everything in this directory. Git commit -b. Lemon feature 2. Now, if we look at Git branch, we'll see that there are 2 branches. One is the master one, the one that's for production, and there's a branch feature 2. The contents of the file, readme.txt, are the one that are for feature 2. And if we go back to our main branch or master branch, we have readme.txt. If we type it, this is our feature, but we are missing everything that we added with the new feature. So the main branch is still what it was when we left.
So every time you change branches, Git, you wipe out your current directory and replace it with. So, you know, if you've got 3,000 modules, that could take some time.
Not really, because it only replaced the changes that were made recently. So it doesn't delete everything.
But then you'd be creating 3,000 new files in that directory.
Only if you change 3,000 files in the branch. So if you're switching from one branch to another, it's going to replay the changes that are needed to switch to that branch. And if there is a file that's not tracked yet, it's going to be untouched. So it's only overwriting the files that are being tracked in Git.
So if the new branch only has one file,
yeah,
then it'll be
only that one.
Yeah,
will be overwritten. But if there is another file that's called hello.txt, and we didn't add it to Git, and we purposely do not add it to Git repository, we instruct Git to ignore that file.
But you can do Git.
You can do that as well. The file or the directory that you told Git to ignore will not be touched at all, so you can switch back and forth. If we look at our history, we have the initial commit and we have added a new feature. Here, if we look at the history of this branch, we have initial commit, we have added a new feature. So everything that happened before we create a new branch is also in the new branch as is history. But we also have another commit that's different from the main branch that's called that has this name implemented feature 2. So now we are satisfied with how our feature works, and we want to merge that onto our master branch.
Could you just do a DIL first?
Sure.
Just curious. Looks exactly the same.
Yeah.
It's version 1. The other one had versions 2 and 1.
Yeah. No, the versions are
You
not.
typed it out.
Yeah. So we are on feature 2 branch. So we're gonna check out master branch. And then we're going to say git merge feature 2. And it says we're updating. It's going to use fast forward strategy. That strategy is when your branch has, the feature branch has branched off the main branch, and then nothing happened in the meantime, it just goes back. So it's like as if this commit was made on the main branch, because there were no conflicting changes there, not.
But if they're working, you're going to demo that.
I'm going to demo that as well. So we're going to start breaking stuff now. Say we have, we're still on the master branch, and let's edit readme.txt. And no, actually, before we do that, let's create a branch. We're going to call it merge conflicts. You don't need to name it that way. He doesn't care, but just for the sake of today. And so now we have a branch that was created. it took a snapshot of the current contents of our readme.txt, and it has a life of its own. Now, before we do any changes in that branch, we're going to make another commit in our master branch, so they will diverge. And we will edit this line because it's easiest to track. So we created a feature three that's on a master branch.
Still on the branch.
Huh?
It gets down.
You're still in the wrong branch, aren't you?
I should be on them. Oh, on merge topic. Okay, yeah, thanks. I'm going to do it the other way around. So let's go back to main branch. So we created a new feature, but then on the master branch there was a conflicting change. Oh. So this is our branch, and our contents say feature 3, and get add, get commit, exam, feature 3. And that's what happened in our parallel reality in a branch that's called merge conflict. These are the contents of our readme.txt. Now we can go back to master branch and make a conflicting change. So we're going to edit readme.txt. This is what we had in master branch. This was still feature 2, and somebody in the feature branch made a feature 3. And we will, in the same line of the file, we'll change it to feature 4 and try to merge that. Get status, get commit -m.
Yeah.
Yeah. Jet lag. Implement feature 4. And I'm going to see it was easier to type. This is what our main master branch looks like. So we added a new feature, we implement feature 2, we implement feature 4, and we have our merging one. And now we want to make a merge conflict. First, we want to merge. It will tell us that it tried to auto-merge readme.txt, and then it compared them line by line, and then notice that in one line of the file, the branches made conflicting changes, so it's not quite sure what to do with that. If the changes were made in non-conflicting lines, say one change was made at 2, and another branch made a change to line 10, it would be easy to merge. We'll just apply those changes. But now we have 2 branches telling us to change contents of one line to two different things. That's merge conflict. And if we look at readme.txt, it looks really weird now. Because we never wrote this CAD and those lines and those greater than less than signs. This is where it gets marked that we have a merge conflict, and it says in your head or the latest commit on your current branch, it says feature 4, and you are trying to merge a line that says feature 3. So just you decide for yourself which one of those will that be, and then go back to me and commit a change, because I cannot decide for you. I just compare files line by line. So we will edit the file manually. And we're going to remove all of those markers. So this is a clear line.
Well, you need a keypad for that, but
Yeah, so we're going to do it manually.
Yeah.
So our merge conflict is going to be resolved by changing this line to feature 3 and 4. And that's our file. And we purge it. Get add everything. Get snap.
Spell it.
Oh,
Fix it later.
yeah.
Your back arrow keyword.
Yeah. So our commit history now looks a little bit. There's a meme saying that it looks like Guitar Hero game because we have lines branching off and then merging back. So what happened in our project is that this was common to all branches, and then we branched off. We implemented feature 4, and then it had a merge conflict with feature 3, and we'll resolve that conflict, and we have merge features, and everything is good again. Our project is stable again. Time permitting, and it does. I can demo how. So,
A couple of questions.
Yeah.
Were you going to move on to the next topic?
we can do questions first.
So on an IDE, you would get a GUI showing you this is feature 3 and feature 4.
Yeah.
Pick one.
Yeah.
You picked a combined solution.
Yeah.
Is there a way to say in Git, let me choose which version, or are you frequently?
Git will ask you to save the file so there is no conflict. So you remove the markers and save the file when you. So we're doing command line here, and that was the easiest way to combine. But when you open IDE and then you just click accept this or accept that, what it does in essence is just removes the markers from the one that you want to discard and just keeps the contents of that and then adds that to Git. So it did pretty much what we did here. Let's see. So we did projects. Okay. One really good feature of Git is that your repository is nice, but it's local. It's only on your computer, and you can work with yourself. But that's pretty much it. And in the repository we made here, one good feature is that Git is distributed. So we can have a central repository somewhere on a SAN or on a GitHub or any commercial service or somewhere in cloud. And then people who collaborate on a project can fetch changes from the central repository, work on their local machines, push their changes to the remote repository. And that way, not only that we have a central repository for all the projects, but also all the developers involved have exact copies of the entire project, the entire timeline of the entire project. So it also adds a little bit of safety. Now, people usually equate Git to GitHub because it's the most popular online repository. But you can create your shared repository on your VMS box on a SAN, on a shared drive. And we're going to do it here. I'm just going to put it in another directory, but it's just a matter of path where your remote repository is physically located.
I have a question. Not that it ever happens in any software I write, but if I wanted to go back to initial commit, could I get back there?
Yeah. We're going to do the time travel later.
Oh, okay, sorry.
Oh, should I do that first? It's very interesting. Yeah. So this is our history. Let's also add a graph. This is what it looked like. And if we want to see our humble beginnings of our project, we can just pick the commit hash, say git checkout this. That's not good at that. Huh. See this.
Get change. For hash, it's the hash, right?
Yeah. So
You say,
you check out this. This should take us to the take the full hash. Oh. Okay, this first. Maybe it was just too short. Yeah. And then when it says head is now at this, to me that it says nothing about. Yeah. So here are again, dive read.txt. And these were our humble beginnings from 35 minutes ago. And it is really good because it not only that it changes additions or modifications to the file, it also remembers the files that we have deleted. So if you have a file that was in a project months ago and it's gone by mistake, we can just go back in our history and fetch the file. And not only fetch the file, but see the whole history of how that file that's now deleted was changed throughout the timeline. All right, previous CAD, but CAD is like on a cassette player, the CAD that reads the magnetic tape. That's why they call it. So it's the current position that we are in our history. And this. So let's see about the remote. So this repository is only in my home directory, and only I can work with it, or whoever has access to that home directory. But it's not really convenient. And for the developer workflow, it's always better to work in your own workspace or your own machine. So we will create a central repository where we'll keep all our changes. It's not going to keep the files. We will not have the files there, just the Git metadata. And those that metadata will be used to replace to clone the project to another box and for other developers can use that to push their changes. All right, okay, let's get that. Right. The directory and solid repo. Our indicator 0. So back to our project. It's 0 DDC. So what did sweet. Remote repositories are exact copies of our local repository, which are just remote. So they might be on a different drive or on a different plan. And we can write to those repositories directly using file operations, but we can also do SSH or HTTPS, and that's pretty much how commercial Git repositories work. We can push all our Git history to our repository. Guess it will take a while. Should have taken this one. Yes, still a work in progress, but we can push our changes to central repository, and then other developers or other coworkers working on the same project can pull the changes, and they can refresh the contents of their repository without changing their file. So if they're on a feature branch, they can get all the changes that were made to the main repository just for informative purposes, so they can prepare their changes. Or so so they know that they will not cause a merge conflict. So yeah, we showed a few basic concepts of Git. We created our project. We created our first commit. We created a branch, did a feature branch, did a few changes there. We also did the merge conflict, we resolved the merge conflict. We showed the syntax for remote repos, but it's pretty much the same thing, but with commands of git push and git pull, where we push the contents of our repository to the remote repository and pull the changes back. The concept of commits is really good in combination with remote repositories, because it allows you to have some triggers that are tied to those events of creating or pushing a commit. So some continuous integration systems can say, you can program that, say that whenever a commit was made on a prod branch, do some automated tests. If those tests pass, then update production, or rebuild a database, or do something like that. Or if there is a feature branch, we can also run the test all the time whenever there is a commit to the feature branch. And then when a code reviewer goes to see the code, he will have the output of the test. We can also do some code quality tools. We can. There's a lot of things that can happen when Git is pushed. Git commit is pushed to a central repository. So key takeaways. Git is a safety net for your work. You can do whatever you want with the files. You can delete, you can purge, you can throw away the disk. As long as there is a copy of your repository somewhere else, you will have the entire history of your project. And just the idea of branching allows you to be much more relaxed which change in which file goes with another file. And then you just have a parallel version of your project that you can do with whatever you want with it. And after that, you can merge that into your project, or you can just toss it if you don't like it. For Git, there are no service required. Everything we did was completely local. And yes, having server is good if you want to collaborate, if you want to do continuous integration, but it's not essential to the function of Git. Also, Git works on OpenVMS via GNV. And your best friends with Git would be a Git status, Git log, and Git diff. Status to see where you're at, what's changed, Git log for history, and Git diff to see what's changed and not tracked yet. Thank you.
How long have you been doing? How long have you been doing it?
About 12 years.
Could you ask it to email members of the group when a change is made?
Yes, there are some Git hooks, and you can configure Git to run in a shell tool in specific positions.
And you can set it to ignore files in the directory if you don't want them.
Yes. So sometimes, a lot of times actually, when you're working on a remote server, it doesn't happen as much. But if you have your ID, your ID will create all sorts of files for itself. But you don't want to share that with your coworkers, especially if they use the same ID. You're going to keep overwriting their changes. They're going to keep.
And you do patterns like ignore star.dat stuff like that.
Yeah, that idea, context code, or
It's just that 86 or
there's a package for Titanium as well, but we haven't tested it yet.
Yeah, it's really a pain. I did try it one time. You got to update runtime libraries. You got to update a bunch of stuff below that so you can update the runtime libraries. And it still works. So it's you really got one.
And as you said, you can have remotes on GitHub. You can have remotes on a Linux box.
Yes, pretty much on anything. So, and you're not limited to one remote. We showed how it looks with one, but you can have as many remotes as you like.
So my question: so can GitHub be a remote?
It can. But you can have multiple remotes. You can have one that's on your SAN. You can have one that's on GitHub. It really depends on your company policy. Sometimes your code shouldn't be on a public server, even though it's a private repository. Company policy says no, that lives on our network. And then you have it on the SAN. You can also, I'm not sure about GitHub,
I think we have our own.
We have our own private.
Yeah, you can have your own instance. GitLab does the same thing.
So why would I do a local version on OpenVMS?
Sure.
And have a version?
Just for redundancy purposes.
If I was observing the code and using CMS terminology,
Yeah.
I would do it locally in VMS.
Yeah,
I wouldn't take it from the cloud.
I mean, if all your collaborators are on VMS.
Yeah.
that's capable. So, but if your collaborators are on.
Yeah, around
A lot of versions.
Yeah.
Different, some are on VMS, some are on whatever.
that's a big advantage. Of Git. It's a platform. Yeah, and plus it's multi-platform, and even once it used to be Linux only, and then when it started using Windows, when it was ported to Windows, you notice that Windows uses different line names because Linux was using line LF and Windows uses CRLF. And then since Git compares files line by line, it's saying each of your line has changed because you have new line annexes to each of the lines. And now it is able to discern between Windows and Linux, and it ignores line annexes. So it is.
Well, VMS uses both. Right?
Yeah.
You look at certain file could be CR delimited, another file could be CRLF.
Yeah.
So is Git aware of checking the VMS file specification before it decides how to?
You can configure it. So if your file started with LFs only, and all the developers are using the same line feed, so nobody is changing the entire file with different line feeds, different line
Record
addresses.
attributes.
So if the bytes in the file don't change, so the end of your line, if it doesn't have an extra CR before that LF,
Yeah.
and it doesn't happen in the same line, Git will not detect that as a change, and it will be fine. But the thing that happens is that Windows editors were quite relaxed about the file integrities, and then they would just redo the entire file with different file index. People would commit that, and then the full file would be marked as changed entirely. And CMS and MMS work together really good. And if your team uses them full time, there's not many reasons to migrate to Git other than a somewhat better branching logic, because branching is the strength of Git. But if you're planning to work with people on different platforms, not only, meaning the code will be running OpenVMS, but if the developers, some of them using Mac, some of them using Windows, it's much easier to do those things if everybody is on Git. It's not easy to.
How we do that? Yes.
Yeah.
We use Git and Bitbucket our strategy for development features, and then we merge to CMS. So once we already done that good tested, we then to CMS.
And there's a hybrid approach as well. You can, instead of CMS, you can be doing Git, but then if your build processes are on MMS, you can do just the builds in MMS and version tracking in Git. So
like it gives you a variety.
yeah. So none of those tools are opinionated, so you're free to use any workflow that works for you. For Git in particular, there are some workflows that's called Git flow or GitHub flow, where it says that this branch will be branched. So there's like main, dev, stage, and then this branch will be branched. The feature branch will be branched out from dev, and then merge it to this, but it's all just a matter of convention. For the functionality of Git, it doesn't really care what's your logic behind it. It only knows that you have this branch, you want to merge it into this other branch, and that's as far as it cares.
Are there any problems during classes? Yeah. You didn't report to the MS. Maybe some workarounds you had to implement using properly.
The only thing is the purge, because Git port doesn't understand the versions.
And after you read the manual, you found that out.
Yeah. But I just learned to use purge before I do any other commands. But the same thing, like when it started Windows, then introduced CRLF. at some point, probably upstream change would be for VMS library Git to also purge files before switching branches or resetting file contents.
So now use the version limit of one or something.
Yeah.
In the dark.
You know, you can set a directory tree, version limit 1, so that every file, just the latest version.
Or we could talk to the PSI.
Uh-huh.
to fix
Yeah.
When was the port done? Is it a new port?
Yeah.
Excuse me? This is a new port. Okay.
It's pretty recent.
Yeah, a few months old, I think.
Yeah.
Oh,
Yeah.
okay.
You said something about, you know, you could script certain things inside of Git. You know, when an event happens, it will kick off like a DCL script. What did you mean by that?
So there are Git hooks
Okay.
that are in Git and they can be hooked into any of the events in Git. So say anytime you create a commit on this particular branch, run this DCL command. So that works. But also the better kind of automation is if your CI server, your continuous integration server, is able to do things like automated testing or deploying or acceptance testing or whatever. It can also react to all the Git commits that somebody has pushed and then retest the code. And there was even a project where I think it was in GitHub. They had a lava lamp, and whenever a branch was broken, that would trigger the lava lamp to turn on. And since it takes about 15 minutes for it to warm up to start working, 30 minutes, one of the policies of the company would be fix this branch before the lava lamp starts working. And then everything was automated, and they had like 15 or 20 minutes to fix the thing that they committed, they changed. And it was like a small Arduino project. It was super simple to accomplish. So there are no limits. You have the event of that, but then you're only limited by your imagination and script.
I mean, you could do it the other way around in the events. You could wrap all the Git operations in a script. Want to make sure that you always call it the main branch, and nobody can ever create main branch in it. And the other branches follow a certain naming convention. So you could script that. Then when you finally collect all the information you have, you create branch. And
there is also an extension. See what it said. So there's an extension to the Z shell. This is so for Macs and for Linux. There's also a similar thing that works on Windows boxes. But what it does is changes your prompt when it detects that you're on a Git repository, and you don't have to do Git status all the time. So
on VMS, I use the host variable status line. So I get to add that.
You can add it. So you just read
at the very bottom of your screen.
Yeah, you just use the output of Git status every time the prompt opens. And then it says we are on main branch and we have this test file. And then I create I change this file. Yes. And you see the prompt is changed because it has a little X there, which means that the directory is dirty. We have a change that was made, but it wasn't added to Git. And then you get add, added, our marker is gone. Also, part of the prompt is the branch we're currently on. I have a newer version of Git which already defaults to main instead of master. But if I create a branch for testing, it's going to tell me that I'm on that branch. So as long as I work on, I will always know where I'm at. And this is just the CLI. And your ID will always tell you what branch you're on, somewhere in the corner of the screen. Xcode does that. All the ideas, VS Code also does that. So the concepts are there. The concepts are quite simple, and being so simple, they can be really powerful because it's up to you to decide how you're going to apply those concepts, or figure out a strategy, or figure out the flows for your team.
I'll say, well, I have one more question.
We got
So-
5 more minutes.
I don't know how many
What do we-
people work in a dirty development environment, but, you know,
Everybody.
I'm somewhere where all the source codes are one. No subdirectories. Just 20,000 files in a directory. So if you want to do a dir,
Go back.
or let's, do a dir of g*.text, take a long time, take maybe 3, 4, or 5 seconds just to do that directory because there's so many files in the directory. So can Git support, so Git will suffer when you change branches. Because each time you're gonna, I guess, only apply the changes, but still, every operation in a directory takes longer just because of the sheer number of files.
Enumerating the
So that's a
directory does.
VMS thing. Like
Yeah.
performance will suffer. Just doing a directory or typing a file will take longer because there are
Yeah,
20,000 files in one directory.
but
Some companies use a command purge.
Yeah, this isn't, I'm not talking versions. I'm talking 20,000 different files, all of which have 100 versions. So, yeah, it's insane.
yeah,
And there's objects in there too. And then the objects have never been purged.
Yeah.
So it's really, but it is what it is.
It's
This
not
is
a-
not the only.
it's not a typical use case, but I think it really depends on which low-level OS calls it's good. And it's possible that DCL is just not optimized for that.
So yeah, VMS.
But DCL and VMS is not
Yeah,
optimal for DIR. It enumerates files and
Not
then
Git's
maybe,
fault.
yeah. But it's possible that that Git will use some other OS call and then it might be faster, but we can test it, right?
So if we chose to reorganize the repos so that files were grouped by functions into subdirectories, and you did a git, you checked out a branch, would you get the directory tree when you check out a branch? How does Git
Yeah,
go?
entire project.
Okay, so it would, and so when you switch branches, you'd still, everything would be in a directory tree split up in the.
If you have changes into 100,000 files, yes, but
Yeah.
usually it's just the ones that.
Okay, good.
Okay.